Hi, Lone Register here. This is my 8-bit breadboard computer inspired by Ben Eater. And if you enjoy this, take a moment or two to go visit his channel and check him out. Or if you really enjoy his work like I've done, become a Patreon supporter of him and support his good work. He's released 10 or 20 videos related to it, and they're absolutely fantastic and has inspired me to produce what you see here. So, what I want to talk about today is I'm going through right now and debugging the motherboard and working on setting up the microcodes. So the microcodes are what drive the control channels that do things on the motherboard. Ben Eater's channel will tell you more about them. But what I've done is I've produced a spreadsheet that actually builds the microcodes and allows me to process them. And one of the challenges I'm running into right now is I have 6 LEDs here that indicate the steps of the microcode that I'm executing. And the problem is the second that I load the instruction register, this guy right here, the memory channels immediately change, and now I'm processing a different section of microcode. What that means is that when I change the instruction register, it can be anywhere in this 1 through 6 step cycle. So right now what I've done is one of my first microcodes is actually at address 0 in memory. I found that the instruction register always loads with 0 on power up. That's, I believe, a property of the 373. I'm not sure. I don't know if I can depend on that or not, but right now that seems to be stable, so I'm working with it. And what I'm doing is I'm executing for the microcode at channel address 0 a few steps to clear things out and set the breadboard computer up. So what it'll do is, since the bus is drawn to 0 via these pull down resistors, I then immediately load the program counter here with the bus, which is all zeros, and I load the address register here with all zeros as well. That way I'm starting at program counter 0 and address 0. Get these two to sync up, and at that point I can then take and load the memory value at instruction. This is the second microcode, the instruction here, whatever it happens to be, into the instruction register. The problem occurs, that's microcode step 2 in my boot sequence. This continues to drive through step 3, and the second that this changes, what happens is it changes where I am in my microcode memory and parameters, and that causes other things to happen that perhaps are not in sequence. So what I think I'm going to have to do is take and put in a 245, that's a buffer, a bus buffer, and essentially create a bus between the instruction register and this chip here. Either that or produce an instruction set, micro instruction set, that actually only changes the instruction register on the first step of any microcodes. That way, anytime I'm on step 1, I know that the instruction set's going to change, the instruction register, and I know that it doesn't matter because microcode 0 loads the instruction register from the appropriate memory address, and that'll switch into whatever other microcode I'm going to work with, and I can operate with positions 2 through 6 of those microcodes. Anyway, quick update. Just wanted to share with you some of the things that I'm processing through right now and trying to debug, and some of the interesting logic challenges that I'm running into as I go through this. Hope your builds are going well. I hope this is interesting to you, and by all means, drop me comments. Let me know what you think about what the solution might be, or perhaps what your instruction microcode set might be. I'd love to hear it. Currently my microcodes are, let's see here, let me just run through them. Load register A or B from memory address, load A from B, or load B from A, so I can copy the registers back and forth. Load A or B register with a static value, clear register A or B with just clearing it, a halt instruction, and let's see here, I've got some test patterns that basically drive through the various configurations of the control codes here, so I can see that they're operating correctly. Adding A to B, of course, subtracting B from A. jump to a static address, jump to a memory address, output A to display, output B to display. I'm also going to create an output bus to display. Output program counter, that's going to help me watch the program counter. And so far that's it for my instruction sets. One of the things that I am curious about is a jump on carry. So if there's a carry value, it'll jump. That would be a simple control code ANDed with the carry signal that would then execute a jump instruction. And then of course jump on conditional. So jump on less than, jump on greater than, jump on equal to, which will then turn this into a very rudimentary 8-bit computer which can do some interesting things. I hope you find this interesting, and have a great day.